Hello everyone, I'm Ajay. Welcome back to the channel. Today again we're going to solve a coding question. Rotate print a matrix by rotating it by 90 degrees. Even this question has been asked in many other tests as well. Coming to the problem description, you will be given a square matrix. You need to turn it by 90 degrees in a clockwise direction. Let's suppose 1, 2, 3, 4, 5, 6, 7, 8, 9. There is a 3 by 3 matrix here. You can see we need to rotate it by 90 degrees, which means 1, 2, 3 will be rotated to here, and 3, 6, 9 here, 9, 8, 7 here, 7, 4, 1 here, and 8, 5, 2 here. So complete 90-degree rotation will takes place, and this will be the output for that. So generally by observing this question, what everyone does is like they just observe that the first leftmost values being replaced with the rightmost, and the bottom value is being replaced with the first one. So such way everyone do, and it becomes a complex thing. So there is just one suggestion from my side. Whenever you get a code, first just observe the code description as well as mainly the input. That's the sample test cases. The sample test cases, sit and observe first. There always a logic behind every input and every output. If you can find that, then your code logic becomes very simple. Observe that, find a logic for that, and just code it. Just don't jump to the code. First observe, then find the logic, then code. Here you can see, let me write the indices for this: 0, 0, 0, 1, 0, 2, 1, 0, 1, 1, 1, 2, 2, 0, 2, 1, 2, 2. I'm using a zero based index, and 0, 0 indicates the first element. So first, this is a row index, and this is the column index. So this is a 3 by 3 fashion for this. So when we do the 90-degree rotation here, this 0, 0 will come here, 0, 1, 0, 2, 1, 2, 2, 2, 2, 1, 2, 0, 1, 0, 1, 1. So this is a 90-degree rotation. As I said, first observe it. And as also mentioned, everyone do this process, and because of that left right replacement, top bottom replacement, the code becomes complex. So I'm just today I'm going to give you and explain a simple tricky way to solve this coding problem. Here you can observe that after rotation, the column count for every row is same: 1, 1, 1, 0, 0, 0, 2, 2, 2. So, and also the column count is nothing but the row value. That is, row value means this is zero. This is a zeroth row. This is the first row. This is the second row. So, column index is nothing but the row value. Fine. We got the logic for the column, and for the row, you can observe that it's starting from the highest index, that is 2, which means the length of matrix minus 1. 2, 3 minus 1 is 2, and it's just decreasing: 2, 1, 0, 2, 1, 0, 2, 1, 0, which means the column is following a fashion of row value of that row, and row index starting from the highest index, and it's just decrementing to the least, that is 0. So we got the column and row. We just need 2 for loops for that. Need to code. So let's code this in Java and Python. I'm using the IntelliJ editor to code this in Java. So let's create a main function and the integer array. I'm using a 4 by 4 matrix. 1, 2, 3, 4, 5, 6, 7, 8. 9, 10, 11, 12. 13, 14, 15, 16. So we have the 4 by 4 launch 4 by 4 array. So let's create a function to rotate this. Static void rotate matrix, and let's accept integer array. And as I said, first the row index, and as here we'll find that the row index is starting from highest and it's decreasing to the lowest. So highest means array dot length -1, because the index starts from 0, so we are using -1. And row index should be greater than or equal to 0, and row index should decrease each and every time. And we also observe that column index is not changing, it's same as the row value, that is for the row. So for that I'm declaring the column index outside this row loop, so it becomes column index. It will start from 0, and this should go till array length -1, which means array length -1, and column index matrices. So you can observe the for loop, the column index is same, but the row value is decreasing, and again the column index will change and the row value will start again. This is the logic which we were talking about. So let's print that matrix dot print. I'm using print because I want the complete row to be printed on a single line with a space between the data. For that, row index, column index, as I said, space. So I'm using a space, and next row should be printed in the next line. So I'm using the system.order printer to print it on the next line. So we have it, and let's call this function rotate matrix and pass this. Let's run this. Okay. So yeah, so it was previously 1, 2, 3. So the complete matrix here being rotated. It was previously the first row was 1, 2, 3, 4. So it's 90-degree rotation. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So this is a simple way to solve. Let's solve this in Python as well. Okay, let's create the list. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Let's first the column index in range of, it will start from 0 till array length -1. So I'm just using array of array. And for the row index, it should start from array of length array of -1, and it should decrement by -1. So that's it. We just print array of row index and column index. Okay. And here you can observe I'm using the print here in the Java, so that the complete solution will be printed on the same row. That's the same row data. But for the Python, we have the parameter in the print function, that is n. N is equal to space, which means after every print statement, this print statement will not go to the next line. Instead of that, it will just print a space. And after each row, I want a empty print. Empty print means in the default code, empty print into end is equal to the next line. So by default, if we are using the empty print, then it will jump to the next line. So I guess code is done. Let's run this. Yeah, so I got the output. So you observe, so you can see when we observe and find out the logic, it became very simple to build the logic. So that's a small suggestion for everyone, and it's a great opportunity from Infosys. Do utilize it, prepare well. And at last, again, once again, all the best, everyone. Thank you.